Unit 2, Exponential and Logarithmic Functions. This section is about properties of logarithms, and I'm never one to say that you have to memorize properties, but you do have to understand them. So I've got them written here, and there are a couple more that I don't have, but these are the basics. So the change of base formula is mentioned in your textbook. We no longer use the change of base formula. It was used when calculators did not have the ability to write a different base other than base 10 or the natural logarithm. And so we won't use it at all. So when it's referred to in the book, or if you see it someplace else, that's what it's referring to. If you have a calculator that does not have the ability to change the base, so say you want to evaluate log base 5 of 25. Our calculators, the TI-84, Desmos, they all can do this subscript of a 5, but if you have one that does not, you would have to write this as log of 25 divided by log of 5, which would then be equal to 2. So we don't need this anymore. Okay, for the properties of logarithms, logarithms make more sense to people if they truly understand exponents. So I can relate all these back to exponents. So the first example, log base a of 1 equals 0. Same thing as natural log of 1 equals 0. Anything that's a log of 1, say log base 7 of 1 is equal to 0. It is because 7 to the 0 power equals 1. So anything to the 0 power is equal to 1. So no matter what the base is, if you're trying to take the logarithm of 1, it's always equal to 0. Log base a of a to the c equals c. Likewise, natural log of e to the c equals c. So if I had log base 3 of 3 to the 4th, this is going to equal 4, because what I'm looking for is the exponent, and that's the exponent. When you're multiplying inside a logarithm, you can split it apart, you can expand it by addition, and this works the same way with exponents. So if I have x to the 3rd multiplied by x to the 5th, I have 3 here, I have 5 here, so this is going to be x to the 8th. So I add the 3 and the 5. If I divide in a logarithm, it's the same thing as subtracting. So same example in exponents. If I have x to the 7th divided by x to the 3rd, I have 7 in the numerator, 3 in the denominator, so the difference is 4. So 7 minus 3 is 4. And the last one is if I have log base a of u to the n, the exponent comes out in front and multiplies by the logarithm. And that can be modeled by if I have x to the 3rd raised to the 5th power. That means I have x to the 3rd 5 times. So x to the 3rd multiplied by 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 x to the 3rd. So I have 5 of them. So it'd be x to the 15th. And that's to me, it's the easiest way to memorize and understand properties of logarithms. In this section, you're going to evaluate logarithms, meaning you're trying to determine the value of a logarithm. So, for example, if I want to find what is log base 3 of 81, it's equal to 4. So I'm looking for the exponent. Log base 36 of 6, it's saying what exponent do I have to raise 36 to get to 6? So I'm raising to the 1/2 power. And I also have negative exponents. Log base 4 of the 1/4. So what exponent do I have to raise 4 to get to 1/4? And it'd be negative 1. So you could think of it this way. 4 to the negative 1 equals 1/4. For this one, 36 to the 1/2, which is the square root of 36, equals 6. And this one is saying 3 to the 4th is equal to 81. Okay, you're also going to expand logarithms, and the purpose is not just for your pure enjoyment. when we solve equations, you may need to expand and condense logarithms in order to solve them. So using the properties that we had above, we can expand this logarithm. So this would be saying log base 3, x squared is being multiplied by y. So I'd have log base 3 of x squared plus log base 3 of y. And it's being divided, so I'm going to subtract log base 3 of the square root of z is going to be z to the 1/2. So then the 2 comes in front. That's where I get the 2 here. There's the only exponent on y is 1, so I don't need to write the 1. And this exponent on the z is a 1/2, and that's where that comes from. When I'm going to condense logarithms, I take something in longer form and I write the word logarithm one time. So this, I gave this example because this is the one that most students, if they mess up one, this is one they would mess up. I have log A, and this is common logarithm, so base 10. Log A minus 4 log B. So let's go ahead and write that. Log A minus log b to the 4th plus log c to the 5th. So this is a subtraction, so that's what's going to go in the denominator, but if it confuses you seeing it this way, we can write addition and subtraction problems in any order we want. So once it's written that way, it's easier to see. A is in the numerator, c to the 5th is in the numerator, b to the 4th is in the denominator.